Hello everyone, welcome to the study of ODE. We are looking at the non-homogeneous part, and today we are considering the second order whereby the constant are variable, the coefficient are variable. So welcome and let us learn together. So we are given this ODE x squared y double prime minus xy prime plus 4y is equal to x sine of natural logarithm of x. So to solve this, we are going to let x squared y double prime to be equal to d into bracket d minus 1y, and also xy single prime to be equal to dy, and also we are going to let x to be equal to exponential t, so that t is equal to natural logarithm of x. So we are going to do this substitution there in this given ODE so that it reduces to d into bracket d minus 1y minus dy plus 4y is equal to, instead of x, we are going to write exponential t sine of t. Instead of natural logarithm of x is t. Then this ODE now it is non-homogeneous, and we are made it to have now constant coefficient, and it has two parts. So we begin with the complementary part, which is given by d squared minus d into bracket y minus dy plus 4y is equal to 0. This can be written as d squared minus 2d plus 4y is equal to 0. We are going to solve this by letting our y to be equal to exponential mx, so that now we are going to get m squared minus 2m plus 4, which is equal to 0. This is a quadratic equation whereby we are going to apply quadratic formula, which states that m is equal to minus b plus or minus square root of b squared minus 4ac divided by 2a. So we apply the quadratic formula, and our m will be equal to 2. Our b is negative 2, so negative and negative will become positive plus into bracket. When you square b squared, it will give you 4 minus 4 times 4, which is here, will give you 16. Over our a is 1, so 2, which is equal to 2 plus or minus square root of negative 12 over 2, which is equal to 2 plus or minus 2 into bracket root I divided by 2. So m is equal to 1 plus or minus root 3i. Then we write our y complementary. Our y complementary will be given by exponential t into bracket sine of c1 sine of root of 3t plus c2 cosine of root of 3t. So that is our complementary part of our given OD. The next level now, we go to the particular part, whereby our particular part yp is equal to divided by d squared minus 2d plus 4. Now to solve this OD, we are going to do it as follows. Exponential t sine of t is equal to, so here where you have d, you write d plus coefficient of this exponent here, which is 1, and you square minus 2 into bracket. Where you have this other d, you write d plus the coefficient of t here, which is 1, then plus 4. That is how we are going to deal with that particular case. So we are going to expand this part here, so that now our yp will be equal to exponential t sine of t divided by d squared plus 2d plus 1 minus 2d minus 2 plus 4, which is equal to exponent t sine of t divided by. So in this case, we have d squared, 2d, and this other 2d, this will cancel. You have 1 minus 2 will give you negative 1 plus 4 will give you or d squared plus because of -1, which is because of 1 plus -2, which give you -1. This is 3, so this is 2. This part here, y complementary is equal to this. So take that. So from here we have exponential t sine of t over d squared plus 2d plus 1 minus 2d minus 2 plus 4. So this 2d and this 2d, this is 2d minus -2d, which cancels. 1 minus 2 is -1, plus 4 will give us plus 3. -1 squared is -1, plus 3, which will give us 2. Now finally, then we write the solution of our own d. So y is equal to y complementary plus y particular, which is equal to exponential t into bracket c1 sine of √3t plus c2 cos of √3t. You close the bracket plus 1 over 2 exponential t sine of t. Finally, we note that x is equal to exponential t and the natural logarithm of x is equal to t. So we substitute here. So our y will be equal to exponential t is x into bracket sine c1 sine of √3 natural logarithm of x. Instead of t, we will write natural logarithm of x plus c2 cos of √3 ln of x. We close the bracket plus x over 2 sine of ln of x. So that is the solution of our given ODE, which was x squared y double prime minus xy single prime plus 4y, which is equal to x sine of natural logarithm of x. That is the solution of our given ODE, which is linear with variable coefficient. Thanks so much for taking your time to study with me this an homogeneous ODE with variable coefficient. Remember to subscribe to this channel so that you don't miss a single video which I upload for us every day. Bye bye. Remember to share with other mathematicians also.